the thing is that you do have to teach people a little bit what science means, because they're very stuck on mathematics and prediction or whatever, but you're really talking about accurate description. That's right, and you have to know we're doing it as construction from first principles. So the thing is, once you, it's an old argument in economic epistemology that if you can't construct it from rational incentives, it can't be true. Now there's a conflict here, which is in economics. I just want to this is profound, so I want to see if I can tie this together without failing. But if you don't understand, in mathematics, we have computational possibility, right, and mathematical reducibility. In other words, what is imaginable is higher than what is computationally producible, and what is computationally producible is higher than what is mathematically reducible. What is imaginable may not be computationally possible. In other words, may not be, you may be able to imagine something, but there's no way to produce a sequence of actions in which to bring it about.
Right.
The same thing happens in mathematics. It may be imaginable, but there's no computational way to construct it. There is also the problem from computational possibility to mathematical reducibility. In other words, can it be reduced to a mathematical expression, which is a general statement of scale independence and invariance? The answer is, the problem is that each one of these things is less. The imagination is big, possibility is less, and reducibility is less so, right? These are smaller sets, right?
But yeah, it's funny because it reminds me of inflation to deflation.
It is, right? I mean,
that's all it is. It's like mathematical fictional to what is.
But the problem is there are some things that are mathematically reducible. That's because they're invariant.
Okay.
Right? There are things that are computationally reducible because they're computationally invariant, but they're not mathematically invariant. In other words, they can't be reduced to a general description. In other words, everything can't be predicted evenly on a trajectory. So, and then there's stuff that's imaginable, like unicorns, you know, that it may be possible to for us to operationally get there, but there's no way to get there at present. I'm going to use a human that's, 100 feet tall. Well, your legs are big, right? That won't work because your legs are right.
Not on this planet.
That's imaginable, but it's not operationally constructible, right? At least on Earth, right? I mean,
right.
Gravity being the bitch that it is.
It's a bitch, man.
The bitch. So, but you may be able to describe it mathematically, right? Right. But you may be able to imagine it, but you can't operationalize it. So the same thing happened in economics, and this is for the libertarians who get confused by libertarian bullshit, sophistry and bullshit, right? So the problem with we call this praxeology. Praxeology is the logic of construction.
Right.
In other words, it's basically constructive mathematics or computability applied to human action. So what is computable, in other words, the combination of human actions that can be brought about, may not be mathematically reducible. That's a stupid question. It's fucking not mathematically reducible. Okay, let me help you. So what happens is you can make a falsificationary statement with computational reducibility. In other words, you can say, I can construct this by operational means, by a sequence of existentially possible incentives and human actions. But it's not mathematically reducible because the categories are inconstant, whereas mathematics depends on relatively constant categories, or at least categories. So mathematics is via positiva predictable, and evolutionary computation is via negativa computable.
Okay.
Does this make so? Mathematics is, we understand it, the art of writing proofs. We think of it, we think of science as justificationary. It's not. If you can write a mathematical proof for it, you've simply said it's possible. Once you know the first principles of the physical world, because they're regular, you should be able to define operational constructability. We're not quite there yet at any level of precision below what you and I use here as the computation of stable relations. Human actions, in other words, recombinatorics, are not mathematically reducible. They are, however, falsifiable. In other words, they're not justifiable, they're falsifiable. It's why I say economists are the one that figured out what's wrong, but they're too stupid to fix it. Mathematics couldn't figure out what was wrong, and they were, when they did discover what was wrong, they were too stupid to understand it. And it just kills me. And computer scientists like stumble on the answer to this question. They're like, well, the economists are too stupid to understand it, and the mathematicians are too stuck and stupid to understand it. And so we're stuck because everybody believes the justificationists, and nobody, because they're, despite that they're wrong, the mathematicians, despite that they're wrong and about that what science means, and nobody believes the economists about what science means because they're only half right. And it's this clown world problem of epistemology that just, it absolutely fucking floors me. And of course, I'm skilled in all three of these disciplines. Right. So to me, it's just like, well, I mean, I'm skilled in logic, or logic of language. I'm skilled in economics. I have more than trivial understanding of the foundations of mathematics and computation. And of course, I have enough knowledge of physics to be dangerous. So the problem here is that you need those competing concepts to be able to understand what science means. How can you testify to the imaginable, the computable, and the reducible? You have to know which thing matters. So it might matter in the physical sciences to create a prediction, but it only matters in economics to create a construction. And for imaginable, it's only got to be meaningful, which means that the relations, the conceptual relations, which are organized by our human minds into objects, backgrounds, and episodes, a couple of other things, it has to only be associable. So associable, constructible, reducible. And so you have this epistemological problem that, you know, there's this whole academy out there teaching absolute fucking nonsense to multiple different disciplines. And it's no wonder that the idea of science can't be reduced to what it is, what we do, which is it's fucking testimony. But you have to be able to testify about which method you're using to deal with which kind of question. Are you dealing with something that's associable, which is basically set logic, something that's constructible, which is operational logic, or something that's mathematically reducible, which is the law of measurements, or what we consider mathematics? Which of those things are you trying to do? Well, because one of them, the first one, it's justifiable and falsifiable why you get there, but it isn't true. The second one is constructible only if it's true, but it's only falsifiable. And the third one is only justification. It's not necessarily true.